In this question, we're calculating escape speed, the speed you have to travel to leave a planet's surface. This problem is a lot like some of the other calculations we've done. The only tricky part is that we have to take the square root at one point, but your calculator should be able to handle that. The escape speed measures how fast you have to travel to escape from the surface of a planet. It also tells us the minimum speed an asteroid has when it hits the planet. When an asteroid gets close to the planet's gravity starts pulling the asteroid towards it. As the asteroid falls closer, it speeds up, just like a falling body near the surface of the Earth. The escape speed is the speed the asteroid speeds up to, assuming the asteroid didn't have any motion of its own when it was far away. If the asteroid was already moving towards the planet, then it could be going even faster than escape speed when it hits. The one quantity we're told in this question is the escape speed from the Earth, 11.2 kilometers per second. You should write that down here because you'll need it for comparison later. This question asks us to predict which planet in the Mystery Solar System will have the highest escape speed and which will be lowest. Notice that it doesn't say inner or outer, so you should be looking at the entire solar system this time. Remember that the escape speed depends on the planet's gravity. The stronger the gravity, the larger the escape speed should be. So look back on what we did to discuss gravity and weight earlier in the course, and use that to help you decide which planets to predict here. You're also asked to predict whether the escape speeds will be more or less than the Earth. You can use the same reasoning here. Compare the size of the planet to the size of the Earth, and that will tell you whether the planet should have a larger or smaller escape speed than Earth. The equation for escape speed looks scarier than it is. It's v escape equals the square root of 2gm over r. V escape is just the escape speed. We've already seen g, m, and r before. These are the gravitational constant, the mass of the planet, and the radius. So that tells us what numbers we have to look up. The mass and radius are given right on the Mystery Solar System table. Don't forget to include the units. You should list these values for all the planets you're going to calculate. That should include the 2 planets from your prediction and at least one more. The gravitational constant is a universal constant, so it always has the same value. 6.67 times 10 to the minus 11 meters cubed per kilogram second squared. The unit conversions here are all familiar ones. We've got the gravitational constant, so we need to make sure the other terms match its units. That means the mass has to change from Earth masses into kilograms, and the radius has to go from Earth radii into meters. Here are examples of doing both of these conversions. After we finish calculating, we're going to want to do one more unit conversion. The answer we'll get will be in meters per second. However, notice that the Earth's escape speed is listed in kilometers per second. So let's change that value to meters per second so we can make the comparison later. Remember that 1 kilometer equals 1,000 meters. So the same will be true for the speeds. 1 kilometer per second equals 1,000 meters per second. So we need to multiply the Earth's escape speed by 1,000 meters per second divided by 1 kilometer per second. That gives us 11,200 meters per second. Now we plug all of the values into the escape speed formula. Don't forget that square root sign. It goes over the entire right side of the equation. We'll do this calculation in steps. First, we'll multiply together everything on the top. Notice that the kilograms cancel out here. Next, we divide by the planet's radius. That makes the exponent smaller, and it leaves us with meters squared per second squared for the units. Finally, we take the square root to get the velocity. If you're not sure where the square root key is on your calculator, it usually looks like the square root symbol in the equation. If you're having trouble finding it, you're welcome to ask for help or look at your calculator's instruction manual. When you take the square root, the number gets substantially smaller here. If you're getting a bigger exponent instead, it means that something went wrong with that step. This number is small enough that we don't really need to use the exponential form of writing it at all. Also notice that the units change from meters squared per second squared to just meters per second. Remember that we're calculating a speed, and speeds always have units that look like a distance divided by a time. Now you should see if your answers make sense and fit your predictions. Remember to answer this part whether the calculations fit or not. Notice that escape speed doesn't change nearly as fast as mass. So even the smallest escape speeds you should see will be around 1,000 meters per second, while the largest should be less than 100,000 meters per second. If the answer is outside that range, there's a good chance that something went wrong in the calculation. Go ahead and check your work, and if you get stuck, feel free to ask for help.